This is the prep packet video for Unit 3, Chapter 8.4, Objectives 1 and 2, and this is Part 1. There'll be several other videos. The first thing we're going to look at is the difference between a rational expression and a rational equation. Keep in mind that an expression is basically just part of a quote-unquote sentence. So I could have 3 over x plus 7 over 4x. There's no equal sign here, so I don't really know what to do beyond simplifying this. And that's all you can do with an expression. An equation, on the other hand, obviously it has an equal sign. So here I could say 4 over x plus 1/2 equals 2/3. And I could eventually take this and I can solve for x. So an equation has a solution. An expression can only be simplified. That's the big difference. And as we work through these, you're going to see that how we handle expressions is slightly different than how we handle equations. So let's look at this first. There is no equal sign, so this is an expression. And what I'm going to do with an expression is pretty simple. I just need to find the least common denominator and adjust it. This is that fine-tuning piece. So between 3 and 6, the LCD, least common denominator, would be 6. This would be a situation with a friends fraction because 3 is a factor of 6 and 6 is a multiple of 3. So all I have to do is adjust this piece. And to do that, I'm going to ask myself, what are the factors of 6? So they're 2 and 3. And here I have 3. And here I have 3. So I need to bump up by 2. And that's going to give me 2 times 3q plus 2 minus q all over 6. And if I distribute that, I'll have 6q plus 4 minus q, which would be 5q plus 4 over 6. Please notice that there is no solution to this. It's unfinished. All you did was simplify. Okay? And I apologize, these problems are slightly out of order on the packet. I adjusted this on the fly and realized that I wanted to present it differently. So now we're going to go back and look at problem number 1. This has this little equal sign right here. So that tells me I have to handle things slightly differently because I'm going to go for a solution here, not just a simplification. So in order to do that, what I want to do is, again, I'm going to look for the least common denominator, which is going to be 12, because 3 goes into 6, but 4 doesn't go into 6. But all 3 of them would fit into 12. So my least common denominator is 12. And this is actually kind of cool what we're going to do here. I'm going to take 12 over 1 and I'm going to multiply each term in this equation by that number. So I'm going to have 12 times 3q plus 2 over 3. I'm leaving those alone. Pay attention, this is pretty cool. And then minus 12 times q over 6, there's that same 6, equals 12 times 3 over, I'm going to go red, 4. Now you notice I still have different denominators, but this is where it gets kind of fun. So here 3 goes into 12 4 times. So I'm going to cancel that out and leave behind the 4. 6 goes into 12 2 times, so I'm going to cancel that out and leave behind the 2. 4 goes into 12 3 times, and I'm going to cancel that out and leave behind the 3. And now I'll end up with no denominators, and I'll have 4 times 3q plus 2 minus 2q equals 9. 12q plus 8 minus 2q equals 9. And so now I have 10q, because I'm combining those two. I'm going to subtract 8 from both sides, and I'll have 1. I'm going to divide both sides by 10, and I'll have q equals 1/10. So go ahead and copy that. I know that went really fast. I would go back and take a look at it again. This technique looks like it takes a lot of time, but you'll see it's actually strangely satisfying because you get to cancel a whole bunch of stuff out. And that's the end of this objective. So go back and copy again, rewatch this one.